today we are going to discuss about the series, right? So series is a sequence written as a summation, right? So here we use the notation sigma. To denote a series we use the Sn, right? Right, because nth term we use an. To denote a summation up to n terms we use the term we use Sn. Okay, right. So just 1 minute. Right. Again, we can use the symbol sigma. Right. Symbol sigma to some. It's something little bit closer to the S. Maybe that might be one reason for using the symbol sigma. Okay. So when you represent a series using sigma, what we do is we do something like this. Right. So this is the notation we use. We use something like this sigma, and here we have to specify what is your starting point. So usually we use something like r, right? R equal 1 maybe to infinity, right? Or maybe r equal 1 to n, right? R equal 1 to n. So then we can say just ar. So this means a1 plus a2 plus keep moving until an, right? Keep moving until a. And again, if it is something like infinity here, then it becomes a infinite series. Infinite series. Then there is no n like this. Of course, there can be a n term, but it keep going forever. Right? Keep going forever. That is how we define an infinite series. Of course, rather than AR or something, we can specify exactly what is our pattern is also. Right? In that case, we can say, for example, sigma r equal 1 to infinity 1 over r, right? So that means 1 over 1, because it's r start with 1, then 2 3 4 1 over 2, right? 1 over 2 plus 1 over 3, you keep move, right, until 1 over infinity, which is 0, right? So that is notation we use. So it is not necessarily start with 1, even it can start with something else also, right? Something else also. So for example, it can be uh, something like r start with 5, right? Then 1 over 5 plus 1 over 6, something like this. And of course it can end somewhere else also. So for example, r start with 5 and r ends at 10. Then when you reach 1 over 10, it has to be n. Okay, so that is the notation we use, right? That is the notation we use when it comes to series. It's very simple thing. Okay, again, just like our concept of convergence and divergence for sequence. So that means the infinite term is a finite value or tend to finite value, reach to a limit to a finite value, then we call it a convergent sequence, otherwise divergent. Similarly, if the summation of infinite term, if it is a finite value, or that summation limit or reach to a finite value, we say that the series is convergent, right? So the same concepts earlier, the infinite term is a finite value or tend to finite value, then the convergent, that sequence. But here, if the summation up to infinite terms, if it is finite value or it is reach or limit to a finite value, we say that that series is convergent. Okay, otherwise we say that that series is divergent, right? So that series is divergent. Again, there are three possibilities a series can be divergent, same possibilities as sequences. That summation is going to be plus infinity. Divergent, that summation is going to be negative infinity or limit to a negative infinity. Again divergent, or that summation is going to be oscillatory. For example, when I have 100 terms, it is plus 5. When I have 101 terms, it is minus 5. Again, when I have 102 terms plus 5, 103 terms, again summation is minus 5. So that means again the summation is now oscillatory, right? In that case also the series is divergent, right? So we can see it's very easy to understand because it's very much like the sequence but different concept. Now we are talking about summation, right? Now we are talking about summation, okay? Then so again you have to understand these two as two separate things. Why? There can be situations where your sequence is convergent but your series is divergent. Same thing, series is divergent, right? And therefore sometimes your sequence is convergent and your series is divergent. Sometimes your sequence is also convergent, series is also divergent. Likewise, there are some different possibilities. Therefore, we have to consider it as two different concepts, right? Two different concepts. Okay, right. So I explained that what is meant by convergent and divergent. Okay, right. So let's take an example also. Uh, so remember last time we discussed about the convergence of a sequence. So it's something like this. So I will take that example again. So sometimes some students find it little bit difficult to understand what is meant by convergent of a series, right? Right. So it's something like this. So convergence is something convergence of a sequence. This is how you usually understand. Say we have. So I gave this example in the class also. Assume that we have a building or something with uh, roof, right? And assume that we have a tree. Right? We have tree or something. Each day this is going to grow, right? At least some growth will be there each day, right? This so this tree is not never going to die, right? So it's getting growth the taller and taller every day, but assume that this tree is never going to grow beyond this forever means after, if I come after millionth or billionth of years of time, still the tree must be not taller than this line for the roof. In that case we say that if I measure the length of the or the height of the tree each day is 5 6 6.5 6.7, right? It has to be increased every day, but if it never going to touch the roof, then we say it's like a finite sequence limited to a limit to a finite value, right? So sometimes you might feel like that is impossible, but yes, for common sense gut feeling that is impossible, but we saw so many sequences that satisfy that, right? So you have to think about it. So I have forgot to mention that last time. For example, the very simple thing is 1.9 1.99. So this is the proper example. 1.999. So the next day 1.9999. Likewise, now you see the pattern. Okay, now you should be able to tell me, right? Now you should be able to tell me. So what is this is a convergence sequence, right? So what is the value that it is going to be limited to? It is going to limit to what? It is going to limit to 2. So if this line is 2, the value is going to limit to this particular value, which is 2, right? Which is 2. Okay, so now you can see it's always the next number is bigger and bigger, but still we are 100% sure it will never go beyond 2, right? It will never go beyond 2, right? It will never go beyond 2, right? So that is the beauty of convergence. So it's counterintuitive, right? So when keep increasing we feel like it is going to be increased forever, right, to infinity, but the reality is that is not the case, right? Why? It is because of the way numbers behave, because every time we are adding a smaller number than the previous one, smaller number, when we keep adding smaller numbers it is never going to go beyond a particular value, right? So that is a beauty of, or the special feature of numbers, right? So same thing now we can extend to series, right? So if these kind of things are possible, now let's see a different thing, that is something like this. Now assume that we have a container, right? We have a container, and every day we are going to add something to that, right? We are going to add, say, some money or something. Some money, let's take some money. So we have a container අපි කැටයක් කියන්නේ. Every day I am going to add something. Every day, right? Every day I am going to add something forever, right? Say after millions of years, billions of years, infinite number of years, I come back. Now remember, from this day one I am keep on adding this, but still this container is not filled. This container is not filled. In that case we say that that series is finite or convergent series, right? So I am keep on adding something to this every day, but it never fill. It never fill, right? Of course, if I am adding some physical things, you might say one day it is going to go beyond that, but I am not adding physical things, I am adding numbers. Again, the beauty of number is numbers are that can happen, that can happen. So that is, we call it a divergent sequence, right? Divergent sequence. So the convergent series. So it's very important to understand, right, without blindly accepting, okay, okay, that can happen. No, so you have to take some examples and think yourself and verify that, okay, that kind of things can happen in the nature, right, in mathematics, right? So that is very important. Okay, so I will just take example, because understanding this is little bit uh, counterintuitive, more counterintuitive than convergence of a sequence, right? But once you take some examples, you will feel like, okay, that can happen, right? So I'll take just one example. uh, I'm taking a geometric sequence and of course series. Say this is one. So I'm just summing that half, 1/4, 1 upon 8, 1 upon 16, likewise. Likewise. If 1/4 is smaller than half, 1 upon 8 is smaller than 1 upon 4, 1 upon 16 is smaller than 1 upon 8, and it is getting closer and closer to 0, nothing. Therefore, we can say, yes, it is convergent sequence. Now let's see the series. Right? Now let's see the series also. Right? So this is 1, then 1.5 is, so up to this it is 1.5. If you take up to this, it is 1.75, right? Then another value will be added, it is going to be more than 1.75. Likewise, so best thing is we can take a calculator and see. So it's very important you spend some time to understand concepts, right? So those people who don't understand and don't experiment with those things, they say that mathematics is difficult. Actually, not mathematics is difficult. You are not willing to spend some time to think about things, right? And understand and make sure that you verify those things to yourself without just accepting, right? So let's take this one. 1 plus zero point 0.5. Sorry, I have to see it. 1 plus zero point 0.5 plus, now it is 1.5, plus 0.25, right? Now it is 1.75, plus 0.125, 0.125, plus, now you can see it is 1.875. So I will just write that number, 1.875, right? It's bigger than 1.75. So let's take one more. Now I took 102, 104, right? And of course I took 1 over 8 though, so now I have to take plus 1 over 9, right? 1 over 9, that is, sorry, not 1 over 9, 1 over 16, so 16, 1 over it, then it will be 1.93, right? 1.93 something. Now you can see that it's getting keep and increasing. But if you try out few more things, right? If you try out few more things, you will see that yes, it is getting increase and increase, but it never going to go beyond 2. If you do this forever, right? 1 over 32, 1 over 64, 1 over 128, etc. You do it forever, yes, it is going to be increase and increase and increase forever, but it's never going to be go beyond 2. So that is a sort of a strange behavior if you just go by your common sense. But the beauty of numbers is that can happen, right? That can happen, that is highly possible. Again, the reason is we are adding a very small number, even smaller number, even smaller number, even a smaller number. That is why this is happening, right? That is why this is happening. Just like well, the sequence can be converged, the series can also be converged, right? Because that sum can also be lesser than the particular value for all the values for infinite values, right? So then we say that series is also convergent, right? So just spend some time to understand what is mean by convergence series. And of course, if the series is not convergent, we say that the series is divergent, right? So that means that your summation of up to infinite terms are either plus infinity or minus infinity, or it is oscillatory. So I will give a very good example uh, for example, sequence is convergent but the series is divergent, right? So that is the tricky thing you have to understand. There are situations where sequence is convergent, series is divergent, right? So sequence is convergent, series is divergent. So that is a very tricky scenario. So likewise, you must have some example for each and every case. You must have examples, right? Not I must have examples. So can someone tell me a sequence or series, right? The sequence is convergent, the series is divergent. So I give you that opportunity because you must have the examples, not me. Me must have the examples, right? Otherwise, you haven't got the idea. So can someone tell me a example where sequence is convergent, but the corresponding series is divergent? So can someone give me an answer? So if you have that answer, that means yes, you have 100% understood because you have examples also. Can someone tell me? Or at least put it into the chat. Situation where, so if you can answer this, I know that you have 100% understood, right? You have 100% understood this concept of convergence series. Give me example where, right? Where that sequence is convergent. Right? Sequence is convergent. So I write it like this: A1, A2, A3, like this. This an term is, or the A infinity is a finite value or limited to finite value. But if you write like this: A1 plus A2 plus A3 plus, of course, an plus A infinity. Of course, this is finite, but the summation is infinite. That means the sequence is convergent, but the series is divergent. Give me example. So then I accept, of course, yes, I accept that, okay, you have fully understood this. So if you can't give examples, no one can argue that, okay, I have understood it, but I can't give an example, right? So that can't be the case. So එහෙම කවුරු හරි කියනවා නම්, හරි, එහෙම කවුරු හරි කියනවා නම් එහෙම, හරි, මට මේක තේරලා තියෙන හැබැයි මට එක්සැම්පල් එකක් දෙන්න බෑ කියලා, ඒක පට්ටපල් බොරුවක්. හරි, පට්ටපල් බොරුවක්. Can someone tell me? So if you can give me example for this, where the sequence is convergent with finite value, but the series is divergent. That means basically it is either I just need something where the series is a infinity, summation is infinity, but the sequence has a finite convergent. There's a very simple example, right? Very simple example. So that is how you have to start thinking, right? Otherwise, you will feel like, okay, I have understood series, but you can't even give an example for that kind of series. So what is the purpose of learning like that? So it's too simple. That is why sometimes it doesn't come into your mind, right? When something is too simple, it doesn't come into your mind, right? So that is a danger, right? So this is an example, the simplest example I can, the simplest one. So always keep in mind the simplest one, right? Something like this: 1, 1, 1, 1, 1. Is it a sequence? Is there a pattern? Of course, this is the easiest pattern in the world. So the next one is also the same one. Next one is the same one, which is 1, 1, 1. So I can keep writing for you 1, 1, 1, 1, 1, blah, blah, blah. Then I will, if someone asks, okay, what is the infinite term? Obviously, infinite term is 1, right? Because when we see that 1, it's always 1. When we go to infinite terms also, it's definitely it's going to be 1. So therefore this is convergent sequence. Why? Infinite term is a finite value, right? Finite value, right? දැන් ඔයාලට මෙහෙම කිව්වම ඔයාලට සැකයක් ඇති වෙයි. දැන් ඔයාලට මේක නොතේරෙන හේතු කීපයක් තියෙනවානේ. ඈ ඔයාලට දැන් මම දන්නවා දැන් මෙතන ඉන්න හැමෝම A එකක් A ප්ලස් එකක් ගන්න නැහැ නේද? සමහරු C එකක් අරන් පාස් වෙනවා. සමහරු ෆේල් වෙනවා. හරි. අපි යථාර්ථයත් එක්ක ඉන්න බෑ. හරි. දැන් මේ විශේෂයෙන් ෆේල් වෙන අය මට තාම ඔයගොල්ලෝ දන්නේ නැහැනේ ෆේල් වෙනවද නැද්ද කියලා නේද? මෙතන හරි. දැන් මේ ෆේල් වෙන අයට තියෙන ප්‍රශ්න දෙකක් තියෙනවා. එකක් තමයි ඒගොල්ලන්ට මේ කතන්දරේ තේරෙන්නේ නැහැ. දැන් මම කිව්වම 1 1 1 1 කිව්වම අනන්ත වෙන සංඛ්‍යාවත් 1 කියලා ඒක සමහරවිට තේරෙලා නැහැ. හරි. ඒකට දැන් ඒක එහෙමයි ඉන්නවනම් ෆේල් වෙන්න කලින් අහන්න ඕනේ නේද? මම කියන්නේ ප්‍රශ්න අහන අය ෆේල් වෙන්න යන අය කියලා. ඇත්තටම වැඩිම මෙතන ප්‍රශ්න අහන්නේ ඕන ක්ලාස් එකක ෆේල් වෙන්න යන ළමයි ටික නෙමෙයි. A එකට A+ එකකට යන ළමයි ටික. හරි? ඇත්ත මේක තමයි දුක හිතන කතන්දරයක් ඇත්තටම. හරි? මොකද ඒ ළමයි තමයි ප්‍රශ්න අහන්නේ. ඇත්තටම අර ළමයි ෆේල් වෙන්නේ තේරෙන්නේ නැති හන්ද විතරක් හන්ද නෙමෙයි. තේරෙන දෙයක් ක්ලැරිෆයි කරගන්න නැති හන්ද. right? So can anyone හරි දැන් ආයෙත් ගොඩක් අයට ප්‍රශ්නයක් අහන්නේ මෙතන මොකද්ද? එයාට මේක පර්ෆෙක්ට් කරගන්න ඕන හන්ද. හරි අර වගේ කෙනෙක් නොතේරිච්ච අය නෙමෙයි අතන ප්‍රශ්න අහන්නේ. හරි තේරිලා පොඩි චූටි කොස්සක් තියෙනවා අහන්න. Right? So now you can see this is a definite pattern. If it is always 1 1 1 1 1, of course the million term is 1, billion term is going to be 1. Likewise the infinite term is going to be 1. Therefore this is a convergent sequence, right? It converges to 1 under the first condition where the value is a finite value, not limit to a finite value, but infinite value is a finite value. Okay, now let's see this as a series. Now let's see this as a series. That means now we know that this is a convergent sequence. Now let's write it as 1 plus 1 plus 1 plus 1 plus etc. Right? So forever, right? Forever. So now what about this? Now for one term it is 1. For two terms summation is 2. For three terms summation is 3. For 4 terms summation is 4. Likewise for 100 terms summation is 100. Right? So right? For million terms the summation is million. For trillion terms the summation is trillion. And of course now you can see that for infinite number of terms now the summation is going to be infinity or infinite value, right? Infinite value. So I don't like to say the value is infinity because there is nothing called infinity as a number. I would rather say the summation is an infinite value. So if the summation is infinite value, by definition, that series is divergent. Right, now you can see the sequence is convergent, but the series is, right, this is convergent, but this is divergent. Right, so that is the simplest example I can think of. Right, of course this is the simplest example. Again, if you take something like 5 5 5 5 5 5 5 5, again the sequence is convergent because it's going to be 5, but the series is divergent because it's going to be 5 plus 5 plus 5 plus it's infinite value. So if you just go by the previous analogy, the infinite value is going to be 5 times bigger than the infinite summation of the previous one. හරි, මේකේ summation එකේ value එක වගේ 5 ගුණයක් විශාල සංඛ්‍යාවක් තමයි මේ 5 plus 5 plus 5 එකෙන් එන්නේ. හරි, ඒතකොට අපි කියන්නේ 1 plus 1 plus 1 කිව්වම තෙන්නේ infinity කියලා. එහෙනම් අපි කිව්වා infinity එක constant එකකින් වැඩි කරාම 5න් වැඩි කරාම තෙන්නේ මොකද්ද? හරි, අපි කතා කරන්නේ constant එකකින් වැඩි කරාම infinity එක අපිට හිතන්න පුළුවන් concept එකක් විදියට ඒකත් ඉන්ෆිනිටිම තමයි කියලා. ඒකත් ඉන්ෆිනිටිම තමයි කියලා. So using that rule, it's not a rule actually, it's common sense, right? Infinity multiplied by a positive value, it is again infinity. That means again divergence. ඒකට වට තේන එකක් ගත්තම දැන් ගොඩක් අය ගොළුවට එන්න පටන් ගන්නවා. So as I was explaining, there can be situations where the sequence is convergent but the series is divergent. Right? Series is divergent, and of course there can be situations where both the sequence is divergent and at the same time series is divergent. So I will take example for that also. Right? So now can you tell me example? I again give you this opportunity. Give me example where both the sequence and series are divergent. So again you have to start thinking now. I will give 1 minute. Now I gave you example where the sequence is convergent but the series is divergent. Now what I need is an example where the sequence is divergent at the same time the series is also divergent. That is the easiest one. Can someone give me example? So if I set your exam paper, right? If of course I'm not going to be the person who is going to set the exam, right? I am going to ask this kind of questions because I know that there are a lot of students who are very good calculators. When they are given the concepts, they can, if for input this is the output, for this input this is the output. They are very good calculators and they are getting very good results in the exam, right? Right, so calculators, right? So calculator do things without understanding what it is doing, right? What it is doing, but calculator is even better than us for arithmetic, right? So don't be like a calculator, right? So be a human, intelligent human, right? So now you have to give me example, right? So for example, calculator will not be able to give me that kind of examples unless it has been taught, right? Of course AI calculators will in the future give examples when we ask something like this, right? For example, I think it's a very good thing, right? So you go to your Google Assistant and ask your Google Assistant, can you give me a divergent sequence and series which are both divergent, right? So the Google Assistant might give some examples, right? Of course the Google Assistant will be using some logic as well as the internet also, right? Anyway, so it's your opportunity now. Give me example where both the sequence and series is divergent, and again if you can give me the simplest possible example, that is really good, right? Simplest possible example. හරි, හැමතිස්සෙම ඔළුවේ තියාගන්න මොකද්ද? මේක තේරුම් ගන්න පුළුවන් සරලම උදාහරණයක්. ඒකට තමයි සරලම විදියට තේරුම් ගන්න. සරලම උදාහරණයක් තේරුම් ගත්ත කෙනාට ඊළඟ ලෙවල් එකේ තේරෙනවා. හරි, සමහරවක තේරුම් ගන්න තියෙන්නේ අමාරු උදාහරණයක්. Right, so I give you that opportunity. Give me example or any examples if you can't think of the simplest possible scenario where both the sequence is divergent and the corresponding series is also divergent. So can someone tell me? So I will take this one. So both has to be, this is the easiest question actually, right? This is the easiest question I can ask, right? For example, I will say one.
Sir.
Yeah. Yes.
5, 5
5.
minus 5, 5 minus 5.
Yes, 5 minus 5, 5 minus 5, something like this. So obviously, this is going to be divergent. Why? Oscillatory. Oscillatory. If a sequence is oscillatory, definitely it is divergent, right? Now let's look at summation. So S1 is 5, S2 is 0, right? 5 minus 5 is 0. S3 is again 5 minus 5 0 plus 5 5. S4 is again 0. Right? 5 minus 5, 5 minus 5 altogether 0. Likewise, your S5 is 5, S6 is 0, S7 is 5, S8 is 0. Now you can see, I can't say exactly what is S infinity also. Just like I can't say what is A infinity, or A infinity is, I can't say which is the value, right? So that means it's divergent. Similarly, I can't say S infinity because it looks like once it is 5, next time 0, again 5, next time 0. We never know whether infinity is odd or even, because infinity is concept. Therefore S infinity is also not determinant, right, or oscillatory value. Therefore this is both, the sequence is divergent as well as the series is divergent, right? Series is divergent. So that is a very good example. It happens to be divergent because of oscillatory nature, right? You can see all the oscillatory sequences are divergent, and of course all the oscillatory corresponding series is also divergent. So that is one approach, right? So that divergent came from oscillatory nature. So now I need another example where that divergence comes from not oscillatory nature. Due to that, it reached to infinity. Now, can you give me that kind of example? Right. So it's both divergent. The sequence and series is divergent. The divergence coming from the infinity nature. Infinity nature. What is the simplest example you can give? Can someone tell? Because nothing much of a theory here. Then we are going to do some fast paper questions. Right. For example, let's take something like this: 1, 2, 3, 4, etc. Now you can see the infinite term is going to be reached to infinity, right? So therefore it is divergent, right? Not because of oscillatory nature, right? And of course when you sum, right, 1 plus 2, 1, of course S1 is 1, S2 is 1 plus 2, which is 3, S3 is 1 plus 2 plus 3, which is 6, right? Likewise this is 6, this is 10, next one is going to be 15. It's getting keep on increasing as well, right? If it is also getting keep on increasing, that means the S infinity is also going to be reach into infinity. So that means it's both, the sequence is also divergent, series is also divergent, right? Okay, so that is something you have to understand. Right, now we have a concept called divergence test. Right, so can someone tell me what is mean by divergence test? Because I did this in the class. So that is the most important thing when it comes to sequences as a concept. What does divergence test says? Divergence test of a series says. Can someone tell me? Because when it comes series, that is the most important test concept other than understanding what is mean by convergence and divergence. Right, divergence test. Right, so what does divergence test says? Right, if when n tend to infinity, an is not equal to 0, right, not equal to 0, then that series is divergent, right? If it is 0, of course the it can be convergent or divergent, right? But if it is not equal to 0, definitely your series is divergent. definitely your series is divergent. So that is a very interesting test, right? Right. So that is very interesting test, very important test, right? So that is it is something like this. So let's take an example. Uh, if you have a series, like for example something like this, 1 plus 1 over half, sorry, just write it as 1 over 1, 1 over 1 upon 4, 1 upon 8, 1 upon 16, etc. Now of course the infinite value is going to be 1 over very big number, which is going to be closer and closer to 0, right? Now you can see the infinite term. A infinity is 0, right? A infinity is 0. What does this theorem says is, if limit n tend to infinity n is not equal to 0, it is divergent. Now of course you can see that this is not the case where a infinity is not equal to 0. A infinity is equal to 0. Therefore by looking at this I can't say whether this is convergent or divergent. This can be convergent, this can be divergent. Why? This value is 0, right? This value is 0, right? Infinite term is 0. When infinite term is 0, it can be convergent or it can be divergent if you just look at this, okay? But if you have series like this, 1 plus 1 plus 1 plus, keep on saying, now what is the infinite term? 1. Now you can see that a infinity is not equal to 0, right? It is obvious not equal to 0. Okay, if the infinite term is not equal to 0, divergence test says yes, definitely the series is divergent, right? So that is how you look at it, right? If your infinite term is not equal to 0, definitely the series is divergent, right? If the infinite term is 0, the series can be convergent or divergent. It doesn't eliminate the possibility of this becoming a divergent, but we know that then it can be convergent or divergent. But if it is not 0, definitely it is divergent. Definitely it is divergent. That is why we call it divergence test, not convergence test, right? Making අපිට ඒක හරියට මේ වගේ හරි. ඔයාලට ටෙස්ට් එකක් තියෙනවා. ඒ ටෙස්ට් එක පොසිටිව් වෙනවා. පොසිටිව් වුණොත් ඔයාලට කියනවා අනිවාර්යෙන් ඔයා මේ වර්ගයේ කෙනෙක් කියලා. හැබැයි අනිත් වර්ගයේ කෙනෙක් එහෙම නොවුණා කියලත් මේ වර්ගයේ කෙනෙක් නොවෙන්න බැරි කමකුත් නැහැ. තාමත් වෙන්න පුළුවන්. හරි? ඒ කියන්නේ උදාහරණයක් විදිහට මේ වගේ. අපි හිතමු කොරෝනා ටෙස්ට් එක ගන්නවා. කොරෝනා ටෙස්ට් එක කරලා පොසිටිව් වුණොත් එහෙම අපි කියනවා අනිවාර්යෙන් ඔයා කොරෝනා රෝගියෙක් කියලා. හැබැයි කොරෝනා ටෙස්ට් එක නෙගටිව් වුණත් අපි කියනවා ඔයා දැන් කොරෝනා රෝගියෙක් වෙන්නත් පුළුවන්. නොවෙන්නත් පුළුවන් තාම. හරි? හැබැයි පොසිටිව් වුණොත් අපි කියනවා ඔයා අනිවාර්යෙන් කොරෝනා රෝගියෙක් කියලා. හරි? ඒක තමයි කිව්වේ මෙතනින් මේක 0 නොවුනොත් එහෙම එයා අනිවාර්යෙන් ඩයිවර්ජන්ට්. 0 වුණොත් තාමත් ඔයා කන්වර්ජන්ට් වෙන්නත් පුළුවන්, ඩයිවර්ජන්ට් වෙන්නත් පුළුවන්. හරි? ඩයිවර්ජන්ට් වෙන්නත් පුළුවන්. right? So that is how it works. හරි? ඒ කියන්නේ ටෙස්ට් එක පොසිටිව් නොවිච්ච අයටත් කියන්නේ දවස් 14ක් නිරෝධායනය වෙන්න කියලා නේද? හැබැයි ටෙස්ට් එක පොසිටිව් වෙච්ච අය කෙලින්ම හොස්පිටල් එකට ගන්නවා. බොහෝ විට. දැන් නම් ගන්නව අඩුයි. හරි? ඒගොල්ලෝ අනිවාර්යෙන් මේව කරනවා. right? Something like that. Right? So that is called divergence test. Right? That is called divergence test. Right? So when n is not equal to 0, it is definitely a divergent series. When it is 0, it can be convergent or divergent. Right? Can be convergent or divergent. So what you have to look at is, look at the infinite term. If someone asks whether a series is convergent or divergent, first thing you want to check is, look at the infinite term and see whether it is 0. If it is not 0, straight away you can say it is divergent, right? So don't do any calculation. If the infinite term is not 0, you can straight away say it's a divergent series, right? But if it is 0, now again you have to keep analyzing whether it's a convergent or divergent. Now you can't say it's definitely divergent, okay? Right. Right. So let's then we discuss a special series, that is geometric series, because it has that convergence nature very prominently, right? So there can be so many convergence series, but for us, one of the most important convergence series that can be convergent is geometric series, right? In geometric series, we know that the nth term is ar to the power n minus 1. the summation of up to n terms is a into 1 minus r to the power n divided by 1 minus r, right? If your r or common ratio is between minus 1 and plus 1, right? Between minus 1 and plus 1, the that geometric series is going to be convergence series, right? Convergence series, and it's going to be uh, converge to this particular value, that is a divided by 1 minus r. So now if you just look at this term, now what happens is, in general, Sn equal a into 1 to the power Rn divided by 1 minus r, but S infinity, if it is convergent, that means r is between minus and plus 1, is going to be this portion, a divided by 1 minus r, right? You can see a divided by 1 minus r. Why it is happening, right? When r is a value with uh, true fraction, what happens is, two fractions, something like this, its infinite term, right, is going to be 0, right? You know that 1 over half, 1 over, sorry, 1 over 1 upon 2, 1 upon 3, 1 upon 10, likewise. Now when you go forever, it is going to be more and more getting closer to the 0. Therefore this r to the power n is going to be 0. 1 minus 0 is 1. That a into 1 divided by 1 minus r is going to be like this, right? So it's not magic. You know, you can perfectly understand why this is happening. Why this is happening? Because of this particular rule. When n r is between minus 1 and plus 1, r to the power n is going to be 0, right? R to the power n is going to be 0, because the fractions infinite term is going to be 0, right? Right. So that is how you understand it, right? So in that case, we say that it is convergent, right? So let's get back to our example. Now what I took is something like this. Now you can see this is a geometric sequence, right? Series, where a equal 1 and r equal half. Remember, when does a geometric sequence become convergent? When r is greater than minus 1, less than plus 1. So for example, when r equal half, when r equal minus half, when r equal 1 over 4. So in those situations, this is going to be a convergent series. So what I took is something like this, where a equal 1, r equal half. Therefore 1 half, half into half is 1 upon 4, 1 upon 4 into half is 1 upon 8, etc., right? Now in this kind of a situation, I showed you that when I keep adding, so I using the calculator, I showed you that it is getting closer and closer to 2, but it is never going to more than 2, right? So this is exactly the scenario where I can use this formula. I can use this formula because it's a geometric series where r is between minus and 1 and plus 1. Obviously, plus our r is half, right? In that case, what we can do is, we can say that, or we can use that formula, and of course by look, first you have to verify whether it's a geometric series, then you have to check whether what is the r value. That's it. If r is between minus 1 and half 1, it's a convergent series. Now if someone asks in the exam paper, if they ask what is this value, of course you can use s infinity equal a divided by 1 minus r. In this case, a is 1, 1 minus r is half, right? So 1 minus half is half, 1 upon half is 2. Now you can see the value is, or the s infinity, the summation of infinite number of terms is going to be 2. Actually that is the value that we have been getting closer and closer in the, when we use the calculator, right? Now you can see 1 plus 0.5 plus 0.25 plus 0.125 plus blah blah blah, it's getting closer and closer to the 2. So this is exactly what we are getting as the from a divided by 1 minus r formula also, right? Now you can see that yes, we can use that formula, s infinity equal a divided by 1 minus r, and of course you can apply this when the r is between minus 1 and plus 1. If the r is not within this range, that means if the r is 2, if the r is minus 5, you can straight away say it's a divergent uh, geometric series, right? Geometric series, right? Okay, so that is the only series we are interested in your syllabus. Of course, if you are given another sort of a series, first we have to check whether the infinite term is infinity, right, or the zero. If it is not zero, you can definitely say it's a divergent series, right? If it is zero, check whether it's a geometric series with r minus 1 and plus between minus 1 and plus 1, then you can use this formula. Otherwise, you have to just look at the formula and check whether it's again convergent and divergent, and if it is divergent, what is the value? Usually you don't get that kind of questions. Okay, usually what you get is a geometric series, right, most of the time, right? Okay, so then we have one more series, right, which is explained in length in your note, right? But we are not going to explain in length because they are not going to test anything on that. හරි පොඩ්ඩක් ඔයගොල්ලෝ බය කරන්නත් එක තමයි පිටු 10ක් විතර අකට දාලා තින්නේ. බය කරන්න බය වෙන අය. හරි. ඒකෙන් exam questions අහන්නේ නැහැ. But just you have to aware of what is mean by power series, right? Power series is something like sigma r equal 1 to infinity 1 over n, right? So when n equal 1, 1 upon 1, when n equal to 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5, etc. So this is called a power sequence or power series. If you have comma separated, power sequence. If you have the summation, power series. So don't confuse this with the previous example I took. Now remember, this is 1 half, 1/3, 1/4. So what I took is 1 half, 1/4, 1/8, 1/16, etc. So this is a geometric sequence and geometric series, right? Because we have common ratio. But what we are discussing here is not a geometric sequence. This is not having any common ratio or common difference or whatever. This is completely different concept. What is known as the power sequence and the power series. So that is 1 upon 1, 1 upon 2, 1 upon 3, etc. So there is no formula to calculate the infinite terms, right? Of course, why? Why? Because the summation up to infinite term is going to be infinity, or it is divergent series, right? So remember, this is a divergent series, right? But this is a series where convergent sequence. Now remember, what does the divergence test say? Again, we have to look at that. What does the divergence test say? Because that is very important thing to understand. So divergence test says is, if a infinity is not equal to 0, that is infinite term is not equal to 0, then it is divergent. If it is otherwise, it can be divergent or it can be convergent. We never know. But if it is not equal to 0, definitely divergent. Right? So as I told you, when the infinite term is 0, that means when the sequence is convergent, still the series can be either divergent or convergent. So this is that kind of situation. You can see this power series, so the power sequence is going to be convergent to 0, obviously, right? 1 over 2, then 1 over 3 is more closer to 0, 1 over 4 is more closer to 0, 1 over 5, then 1 over 10, 1 upon 100, 1 upon billion, 1 upon million, right? So it's getting closer and closer to the 0. Therefore, this is a convergent sequence, right? Convergent sequence, but this is a divergent series. Divergent series. If you keep adding, right, 1 plus 0.5 plus 0.33, right, 0.25, you add it forever, it is never going to reach to a value. So therefore, this is a very interesting sequence. Actually, a lot of people in the history has thought and assumed just like you. I hope that you will also feel like that, right? So they had thought to assume that, okay, this is where the infinite term is also 0, therefore this is going to be a convergent series, but it never happened to be. So this is a convergent sequence where the series is divergent. That means this value is 0, right? This the a infinity is 0, but remember, when a infinity is 0, according to divergence test, we can't say anything about that. What we can say is it can be divergent to convergent. This is that kind of situation where the a infinity is 0 and the series is divergent. Right? A infinity is 0 means obviously the sequence is convergent, but the series is divergent. Right? So that is something you have to understand. But when you take this example, right? So when you take this example, you can see that the sequence is convergent because it limits 0, and also the series is also convergent. Now you can see this value is 0, both the sequence is convergent, series is convergent, right? Sequence is convergent, series is convergent. That is the case when it comes to infinite geometric series where r is between -1 and +1. But in this situation, uh, so the infinite term is 0, therefore the sequence is 0, but the series is divergent. Series is divergent. Right? So that is why the divergence test only talk about when it is not equal to 0 divergent. When it is equal to 0, it is silent. It is not saying whether it's going to be convergent or divergent because both the possibilities are there. Right. So let's take the 2019 paper. Right. So we did this, right? Ninth one we did. Actually, not much sequence series question in 2019. We did this one also because it's again sequence. Yes, that's it. So there's no series related question there. There is no series related question there. So let's move to 2018. So we discussed the eighth one, which is sequence. Ninth one also we discuss. 10th one also we discuss, right? So it's keep on repeating question. Okay, so no series question. No we have a series question. Two questions, right? Two questions. Uh, for this 14th question, you need a concept called partial fractions, right? Partial fractions. Therefore, I am not going to do this question right now because the concept of partial fractions I am going to take as a separate topic because it's actually we are supposed to discuss it under integration, right? Integration. Therefore, what I am going to do is I am not going to take this question right now because we haven't discussed the concept of partial fractions, right? So those who have done A level maths know this. බින්න භාග කියලා වෙනම topic එකක් තියෙනවා ඒගොල්ලන්ට. හරි ඉතාලම lazy topic එකක්. හරි. So we will do this once we do that, right, theory part. Anyway, I will try to do this today itself if I have time, right? Because it's not nothing to do with integration. It is something related to algebra, but they have put it into the integration. Okay, so therefore just let's keep it open for the time being. Okay, because I need that concept called partial fractions, right? Right. So the 15th one. So you have been given a series, and they ask whether that series is divergent and blah blah blah, right? So now you can see straight away what is that series. Now you can see the infinite. First look at the infinite term, right? If the infinite term is not equal to 0, definitely that series is divergent, right? So systematically හිතුවම මොන question එක ලේසි මොකද අපි concept එක infinite term එක 0 නම් 0 නෙමෙයි නම් ආයි බලන්න දෙයක් නැහැ ඔක divergent. හැබැයි infinite term එක 0 නම් අපිට බලන්න වෙනවා ආයි තව ටිකක් කල්පනා කරලා බලන්න වෙනවා මොන වගේ එකක්ද මේ කියන්නේ. මොකද 0 වුණාම මේක convergent වෙන්න පුළුවන් divergent වෙන්න පුළුවන්. So කොයි වගේ එකක්ද මේක? So infinite term means you can see it's getting closer and closer to 0, right? 1 over 5, 1 upon 6, 1 upon 10, right? So it's infinite term is, right? Infinite term is uh, getting closer and closer to 0. That means this is a convergent sequence, right? So convergent sequence. Now a convergent sequence which reach to 0 also, when it is reaching to 0, our divergence test says it can be convergent or it can be divergent, right? Now we have to check whether what kind of a thing is. First thing you have to look at is whether it's a geometric sequence or series where r is -1 and +1. Obviously no, right? No, but you can see that the series is the series that we discussed last. What is that? The series is the power series, right? So the series is the power series, right? We know that the power series, though the sequence is convergent, the series is divergent, right? So series is divergent. So therefore, this is divergent. Of course, when how can it get in divergent? Because it's going to be bigger and bigger and bigger and bigger, not by oscillatory. Divergent වෙන්න පුළුවන් විදිහ එකයි තියෙන්නේ. එක්ක oscillatory වෙන්න ඕනේ, එක්ක plus infinity වලට යන්න ඕනේ, නැත්නම් minus infinity වලට යන්න ඕනේ. ඔච්චරයි වෙන්නේ. සීක්වන්ස් එකක් වුණත් එහෙමයි, සීරීස් එකක් වුණත් එහෙමයි. එහෙනම් මේක divergent නම්, හරි? ඒ කියන්නේ මේක 0 මේ divergent වෙනවා නම් සහ මේක oscillatory නැත්නම් අනිවාර්යයෙන්ම මොකද වෙන්න ඕනේ? It must be, you can see it's not going to be negative infinity because all those are positive values, right? And therefore it is going to be bigger than 1000, bigger than 10,000, bigger than 1 million, etc. It's actually going to be infinity, right? Infinity. So you can see that it is a power series. For power series, is sequence is convergent, series is divergent. So if you take your note, හරි මේක අහන්න හිතන්න එපා මේ සිලබස් එකෙන් පිට ඇහුවා කියලා නෑ. ඔයාලට මෙච්චරයි දැනගන්න ඕන පවර් සීරීස් එක ගැන. හරි. හැබැයි ඔයාගේ පිටු 10ක් විතර ඔයාලට එක්ස්පෙක්ට් කරනවා මේ පවර් සීරීස් එකේ තියෙන ප්‍රොපර්ටිස් ගැන ඔයාගේ නෝට් එකේ. හරි. මම ඒවා පොඩ්ඩක්වත් කරේ නෑ. අපිට ඕන ඔය ප්‍රොපර්ටි එක විතරයි. හරි. අපිට ඕන ඔය ප්‍රොපර්ටි එක විතරයි. So you must be able to identify power series, right? Identify power series. That's it. Then you have to know those two properties. So this is about geometric series. Right, you can see power series, right? So that is that is what we need. So you can see they have introduced it in a very complex way, but what we need is a very general understanding only, right? Very general understanding only. So ඒකයි ඔයගොල්ලෝ බය කරන්නත් එක්ක මේ දාලා තියෙනවා. අපි අනුකල්පනයක් දාලා හරි ඒක බය වෙන්න එපා, right? exam එක ටෙස්ට් කරන්නත් නෑ, right? Right. So what we have to know is this is a power series. Therefore, it is a convergent sequence, but divergent series where the value is going to be reach into positive infinity. So therefore, answer is it's a divergent. Of course, the sum is larger than 1000. Right. So you can't say smaller than 1 lakh, right? Because it's going to be plus infinity, right? You can't say sum is smaller than 1000. You can't say the series because they are talking about the series. Series is not convergent. Series is divergent. Okay. Right. So that's the 15th question. That's it for that paper series, because sequence questions anyway we did. You can see these subjects are very, right? It's very simple, right? Who says that maths is difficult? Someone crazy. Right, so let's move on to the next paper. Did we do that? This one, ninth one, it's anyway sequence. I think we didn't do this, right? Can someone tell? Okay, so let's do this. I think we didn't do this, though it's not related to series. So therefore, let's take that. Right. So the question says xn plus 1 equal 1, x1 equal 2. Find the x100. Right. Again, what you have to see, if it is a sequence and series question, see the pattern. Right. So අපි වෙනම කුත් කරේ නැහැ මෙච්චර දවස් මේ ගණන් හදද්දි. So therefore, they have given x1 as 2. Now we are going to use this one, right? So let's say n equal 1. In that case, x1 plus 1 plus 1 is 2, x2 is 1. Now we have already found x1 is, they have given x1 as 2, therefore we know that x2 is 1 minus 2, which is minus 1. Now let's say n equal 3 to this one, right? Because here is just x1, x3, so sorry, xn equal 2, x2 plus x3 is going to be 1. Now we know x2, therefore x3 is going to be x2 is minus x2, that is plus 1. 1 plus 1 is 2. right? Now let's say n equal 3, then sorry, n x3 plus x4 is 1. Now we know that x3 is 3, right? x3 is 3. Oh, I made a mistake. I think I made a mistake. Let's do it from the beginning. x1 is 2. 2 plus x2 is 1. 1 minus 2 is minus 1. Fine. N equal to x2 plus x3 is 1. We know that x2 is minus 1. So minus 1, when you go there, it will be plus 1. Sorry, this one is 2. This one is 2. So this one is 2. x3 is 2. Now this is 2 plus x4 is 1. That means x4 is again minus 1. Right, minus 1. Now you can see that the x1 is, so this is 1 2 3 4, right? x1 is 2, x2 is minus 1, x3 is 2, right? x4 is minus 1. Now you can see the pattern: 2 minus 1, 2 minus 1, 2 minus 1. When it is even, minus 1. When it is odd, 2. Now what they ask is x100. Of course 100 is even. When it is even, it is going to be minus 1. So the answer is minus 1. If they ask what is x101, it is going to be 2. Right, because it's going to be 2 minus 1, 2 minus 1, 2 minus 1 oscillatory sequence. Okay, so I will just double check the answer now. Yes, answer is C. Answer is C. Okay, so that is how you do that. So let's move on. Right, so they have given another question. If the third, fifth and eighth term of non-constant arithmetic progression, right? So it's an arithmetic progression. I think we did this. අපි කරාද? නෑ, කරේ නෑනේ. So why you are very silent? Did we do this? මේ කරාද? කරේ නෑ. Right. So assume that we didn't do this. Right. So right. So it says if the third, fifth, and eighth term of non-constant arithmetic progression are three consecutive terms respectively of a geometric progression. Right, so third, fifth, and eighth. So let's write down this. I'm going to the whiteboard because I need a little bit more to explain here. Control A, delete. Right. So the question says, I'm going to close this. For third, fifth, and eighth arithmetic progression. Third, fifth, and eighth. If it is arithmetic progression, it's something like this. Let's say A1, A2, A3, A4, A5, A6, A7, A8. Right. So if it is arithmetic progression, right, arithmetic progression, it must be A plus B, A plus 2D. So you have to have a lot of patience. A plus 3D. This is a little bit difficult question. A plus 4D, because they have given up to 8 terms. We want to find some relation. A plus 5D, A plus 6D, A plus 7D. Right. So what they are talking is third, fifth, and eighth terms of non-constant arithmetic progression. Third, fifth, and eighth. Okay, so I am just marking third, fifth, and eighth. Right? So third, fifth, and eighth. So that is I'm interested about this term, and this term. Right? And so the question says three consecutive terms respectively of a geometric progression. Right? So those are the three consecutive anuyata consecutive terms of a geometric progression. Right? Geometric progression. Then what is the common ratio of the geometric progression? ini common ratio එකයි අහන්නේ. ඒ කියන්නේ මෙන්න මෙයා. මෙයා මෙයා මෙන්න මේ තුන් දෙනා ජියෝමෙට්‍රික් ප්‍රොග්‍රෙෂන් එක එක ළඟ පද තුනක්. ඒ කියන්නේ අපි හිතමු මේ පළවෙනි පදේ කියලා. එහෙනම් මෙයා A, මෙයා AR, හරි. ඊළඟ පදේ නම් AR වර්ගය. Right? AR squared, because three consecutive terms, right? Three consecutive terms. What they ask is, what is this R? Right? So that is your question. And now you can see, බැලුමට මෙලෝදියක් නැහැ දැන්. අපි ඒ දන්න මේ R තමයි හොයන්න කියන්නේ. හරි. මේ නම්බර කීයද කියලා දන්නේ නැහැ තාම. මේ නම්බර කිසිම අයිඩියා එකක් නැහැ. Highly abstract question, right? Highly abstract question, right? And we can see answer is just a number. Answer is just a number. So that means though it's a very abstract question, we are going to get a specific value like 1 or 2 or whatever, half or whatever, right? So let's see how to do this kind of question. So what can we do? Okay, let's write something like this. This divided by this must be same as this divided by this, right? So let's write like that. A plus 4D divided by A plus 2D, right? This is this term and this term must be same as A plus 7D divided by A plus 4D. Right? So that must be the case because it says that these three terms are consecutive terms of a geometric series. 4D squared, right? So I'll just say A squared plus 8AD plus 16D squared equal here A squared plus 2AD plus 7AD plus 14D squared. Let's see whether we can solve like this. A squared to A squared will cancel out. Right? Here we have 7AD, 2 CDs, 9AD. 9AD, but anyway A is not going to be cancelled out, right? Anyway, 16D squared minus 14D squared is 2D squared. From there 7 plus 2 is 9, 8 minus 9 is minus 9 minus AD equal 0. Right? So 16D squared minus 14D squared 2, 8, 7 plus 2 is 9, 8 minus 9 is minus AD. Right? So let's take D out. Let's take D out and see whether we can find a solution like this. D 2D minus A equals 0. So that means D equals 0 or D equal A divided by 2. But that is not a solution for us, right? That is not a solution for us. Why? What we need is this ratio, right? What we need is this ratio. It looks like it is not going to solve the problem, right? So therefore let's see in a different way because we didn't get a proper value, right? Or can we substitute here because what we need is R, right? Now we have the D value using A value, right? So let's do that, right? Because now we have the D value using D is A divided by 2. So let's put it there because this is the common ratio. What they ask is what? Common ratio, right? So let's put it there and see whether we are getting the answer. What is the value of A? Sorry, D is A divided by 2. D is A divided by 2. Let's say A plus 4 times d is a divided by 2 divided by a plus 2 d is a divided by 2. Now you can see a is common, it will cancel out, right? It will cancel out. Here it is going to be 2, here it is going to cancel out. Then 2a plus a is anyway 3a divided by a plus a is 2a, so we can cancel out a, so the answer is 3 divided by 2. So let's see whether we have that kind of answer. 3 divided by 2, yes, 3 divided by 2 is there. I will double check the answer. This is I think 2016 10th question. Answer is a. Yes, answer is a. 3 divided by 2, yes, the answer is a, right? Answer is correct, right? 3 divided by 2. So what we got is, I hope what we got is 3 divided by 2. Yes, now you can see. So you have to need lot of patience, right? Don't හරි වැඩි අතරමඟ අතාරින්න එපා. මම දැක්කනේ මාත් නිකන් පොඩ්ඩක් මටත් මේ question එක ඇත්තටම කරලා තියුන්නේ නැහැ ගිය අවුරුද්ද කරාට පස්සේ. Right? But you can see, so somehow see a pattern, right? So because I just wrote this as the terms, then this is your arithmetic sequence, then they say the third, fifth and eighth terms are the consecutive terms in your geometric sequence. Therefore I know that the common ratio of this divided by this must be same as this divided by this. uh, I was little bit shaky because there are two unknowns, right? I thought that straight away I might get A or D, but it never happened. I just got the D in terms of A by 2. But anyway, they have not asked you to find the first term A or whatever. What they have asked is R. Therefore, I just substituted here, right? Again, uh, D value using A, then A cancel out, and I got the value as 3 divided by 2, right? 3 divided by 2. So again, you take your time and do these questions. I think this is a very interesting, very abstract questions where you feel like sort of impossible, right? So those are the very abstract questions, right? Anyway, you don't have a concept called abstract algebra, abstract algebra. There's a concept called abstract algebra also, which is not in your syllabus, right? So I hope you got it, right? So anyway, it's a fairly demanding question, right? Fairly difficult question. Okay, right? So let's look at this one. So this one we can do only when we discuss the limits, right? When we discuss the limits, right? So therefore I'm not going to do this because this is basically a limit question that we are going to do under calculus, right? Under calculus. So therefore just mark it and remind me later when once we do the limits. Okay, right? I think that's all for that paper. No other sequence and series questions. Anyway, that this question is very easy, right? Very easy question. We will be doing this once we do the limits. Okay. Okay, so that's it. So those are the questions you have for the past 4 years. You can go through the rest of the stuff. So basically we are done with the sequence and series.